How to solve for the ln of x in this formula. I discovered this formula for solving for the ln of x. And with this one, I added the ln of x over 2 to increase the accuracy. So now we have a formula ln of x equal to 2048 multiplied by quantity x raised to the 1 over 2048 plus ln of x over 2 minus 1. So the problem now is how to isolate this ln of x into one side to solve for ln of x, because this is a more complex exponential equation. So simplification of the formula to isolate ln of x does not look easy, but the exponential number of x raised to the 1 over 2048 plus 1/2 of ln of x can easily be resolved into a fraction that can be simplified from a previous video of approximating special cases of exponential numbers. A number whose root is a power of 2, where root n greater than 10. In this case, x raised to the 1 over 2048 equals to x raised to the 1 over 2 to the 11th power. Since the 2x raised to the 1 over 2 raised to the 11 plus 1/2 of ln of x is close to x raised to the 1 over 2 raised to the 11. This can be approximated by my method used in those special cases, wherein x raised to this 1 over 2048 plus a small number 1/2 of ln of x is approximately equal to x raised to the 1 over 2048 minus 1 multiplied by this ratio of 2048 divided by 2048 plus 1/2 of ln of x plus 1. Substituting formula B into formula A, ln of x therefore equal to 2048 multiplied by quantity x raised to the 1 over 2048 minus 1 multiplied by this ratio of 2048 divided by 2048 plus 1/2 ln of x plus 1 and minus 1. So this 1 and minus 1 will cancel out. So therefore ln of x equals to 2048 multiplied by x raised to 1 over 2048 minus 1 multiplied by this ratio. And transposing ln of x divided by 2048 equals to x raised to 1 over 2048 minus 1 multiplied by this ratio. Cross multiply and you'll have this. And multiply both sides by 2, you'll get 4096 ln of x plus ln square of x equals to 2 times 2048 times 2048 times x raised to the 1 over 2048 minus 1. Transposing and rearranging, ln square of x plus 4096 ln of x minus 2 times 2048 times 2048 times x raised to the 1 over 2048 minus 1 equals to 0, which is a quadratic equation in terms of ln of x. Solving by quadratic formula, therefore ln of x equals to minus 4096, that's the B value, plus supposed to be plus minus, but since negative ln of x cannot have negative numbers, so I just use positive. 4096 plus square root of 4096 square plus 4 times 1 times 2 times 2048 times 2048 times x raised to the 1 over 2048 minus 1. So ln of x rearranging will be like this, in which this multiplied by that and that multiplied by that, the 4 will be rearranged into two 2's, and therefore you'll get a 4096 square here and a 4096 square there. So you move it out and you'll have this equation. So ln of x is equal to negative 2048 plus 2048 times square root of 1 plus 2 times x raised to the 1 over 2048 minus 1. Expanding inside, you'll have 1 plus 2 x 1 over 2048 minus 2. And the final simplification will be ln of x equals to 2048 multiplied by quantity square root of 2x raised to the 1 over 2048 minus 1 and then minus 1. For larger value of x that could be greater than 1 million, you can use this one, ln of x, just changing this 2048 into double it, become 4096. But inside you also have to raise the value of x raised to the 1 over 48. And if you use a value twice of this, 1892, you'll do the same inside. Square root of 2x raised to the 1 over 1892 minus 1 minus 1. And if you double this again, this one is for a very ln of a very large number. ln of x equals to 16384 multiply quantity square root of 2x raised to the 1 over 16384 minus 1 and minus 1. Example, let's find the ln of 3. We input 3. We use the 2048. That means it's pressing the square root 11 times. 6, 7, 8, 9, 10, 11. Then you multiply by 2. Then you minus 1. And you get the square root of that. And you minus 1 again. And you multiply this value by 2048. And there you have the ln of 3. Next one, we try to find the ln of 100, but we'll use the number 8192 instead of 2048. So 1000, that means 8192 means pressing it 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then multiply by 2 equals minus 1 equals, get the square root of that and minus by 1 and then multiply by 8192. And that is now the ln of 1000. And now we try to find the ln of 1 million. And this time we're going to use the 16384. That means pressing a square root of square root key 14 times. Then multiply by 2 equals minus 1. Get the square root of that and minus 1 and multiply by 16384. And that is now the ln of 1 million. And from here we can see the result. ln of 3 is this one, the true value from a scientific calculator, and the error is this one, 0.000034%. ln of 1000 using the 8192 formula, and you'll get this value, 6.90775597056. And the true value is this one, accurate up to this point, 7755. And the error is 0.00001%. And this one is for the ln of 1 million. Substituting into the formula using the 16,384. Oh, this one has to be multiplied by 16,384. And using this number 16,384, and you raise that to the 16,384 power. And this means if you use this number, you have to press square of key 14 times. And this is the value, and this is the true value, and the percent error is the same as this one, 0.00001%.